So this is the extended example, not extensive example, extended example of object-oriented programming. And this is an example of a person, and then MIT person, and then student, undergrad, professor, Gridbook. Finally, we actually also go over some generator. So for this example, we also have used the date and time as the data type. So the date and time data type is a very special data type, not just in Python, in many languages. For example, February 29, it doesn't occur every time. It only occurs in leap years. Also, after January 31st, we don't have a January 32. We actually have February 1st. So it's discontinuous and it's jumping. And it also has some irregular, well, seemingly, mathematically, they do follow some formula. But the good thing is, in many programming languages, including Python, we have a special data type. In this case, we call the DataTime package to handle this. So we can import DataTime. You can actually read the manual to how to use DataTime, but this is probably one of the most common data type package we have to use, especially for many data sets, including, say, a customer survey. You will have a timestamp. And the data type is also cumbersome in a way. United States, European, many other countries may use different format, right? So in the US, the convention is a month, date, and a year. In many other countries, the standard format is a year, month, date, right? So if we don't have a package to handle this, it will be quite cumbersome. The Python data and time is a package basically handle all this conversion behind the scene. So in this case, we have the DataTime.date. That's the function to create a date object. So DataTime is a class. Date is a method there. A DataTime control with the year, month, and date will return an object of the DataTime class. So here I'm basically calculating the difference between, oh wait, that today is March 35th, is it? Yes. So, and then to March 15 isn't the last year, the time UTC closed, roughly. So it has been 375 days since we going into this pandemic mode. So it has been a long time. Yeah. So 375, more than a year. This is actually regular because each year is 365, and we are 10 days after that. That's 365 plus 10, so 375. There's no leap year here. But if you are, say, 2011, that's when that's the day when the Twin Tower, oops, that's not it, hit a Twin Tower at New York City was hit by planes. So how many days past that? 7,500 days. Oh wow, 7,500 days after 9/11. So okay, this is just a handy way to handle data time in Python. And for this exercise, we also use some string operation. We may actually go into it and then come back. So let's first look at the person class implementation. So we use DataTime package. And for this person class, we have the name. So those are instance variable: name, birthday, and last name. Notice the last name actually came from the input name. So when we define the class, we only have a self and a name. So name is the only required parameter when we created a person object. The last name actually is inferred behind the scene in the constructor. And then we have other methods like get last name, set birthday. So apparently, the way we are actually setting the birthday not in the constructor by using this function set birthday. So, and that's month, date, and year, and that's the United States conversion. But when we actually call the date method, this is actually the European conversion of, I guess we call that international conversion. Yeah, so year, month, and date. That's how we call that date function. That's it. And I guess since we are doing this in the US, we have the APR, which is follow the US convention, but behind the scene, we are using a European conversion. So, but this is taken care, assuming in the US, when a customer input the date, behind the scene, they don't have to do that conversion. So, and then return the age, and the person also override this comparison. And in this case, we have compared them by their last name. Later on, you will see for the MIT instance, we override this again, but not for the last name, actually for the ID number. So, okay, so now let's come back to look at this part. How do we get the last name from the name input? So this is basically using the string operation. So in this case, if I had hello UTC, it's a springtime. And then we just split this string based on the empty spaces. So, and this is actually how it come out. Hello UTC, it is springtime. Maybe I change that. Hello UTC. Today at 2 p.m. So, right, so there. And this is basically a list, right? So the list, and the textbook basically, if we pick the last, excuse me, the last element of the list, that may be the last name. So for example, Tom Brady, if we split this and take the last element, that would be Brady, right? So that would be the last name. The problem is if we have a three-word name, like this Manfred von Richthofen, I think that's the Red Baron, as we mentioned last time. If we do this, then this person's last name is missing a word. So another way to do this is actually just to remove the first one and just use what's the rest of it. So in this case, we can split the name, but instead of taking the last one, we can pop the first one and then join what's ever remaining. That will be the last name. So that's another way to handle the three-word name. So, okay, but for what's the textbook version, we're going to just assume everybody's name is just the last one. So, and if you want to modify that, you can actually write a few more lines to just take whatever remaining, pop the first word and use what's remaining for the last name. And in some cases, some people don't have a last name. This happened for some, like there's some famous singer had just one name. And there are also some royal persons, like I know in Japan, the emperor and the prince only have one name. They don't have last name. In Japan, the emperor or royal family, they only have one name. There's no last name. That's so. In some cases, how to deal with that will be actually in that case, it's also become a tricky. If I pop the first one, there's nothing left. So yeah, but despite the way we can try to deal with it, it's not always still doesn't always fail selfly, I guess. Yeah. So, okay, but since this is OOP, we are going to ignore those abnormal names. Okay, this is a person's name, a person's class, and we are going to create a few instances of this person class. So person. Mark Zuckerberg, birthday May 1484. That's probably the real his real birth date. Drew Houston, Bill Gates, 1955. And then we also add a person called Andrew Gates and Steve Wozniak. Oh, it's another Apple co-founder. I don't know the Drew Houston and Andrew Gates, but these two doesn't have a birth date because the constructor does not call for it directly. So we have 1, 2, 3, 4, 5 instances of the person. I'm going to run this, make sure run everything before I run this. Okay, but once we have all those instances, we actually can use it just as any other data type. We can put this in a list. Right? So now we can have a list of those instances of persons. So P1, P2, P3, P4, P5. That's a person list. So, and then we can actually print out all the elements, see what they are. So in this case, because when we override the string function, we just return the name. So there. So Mark Zuckerberg, Drew Houston, Bill Gates, Andrew Gates, Steve Wozniak. And this is basically the input order. Now, once we have all the instances in the list, and we also have which is less than comparison function, it turned out we can also use that to apply other operation, like the common list operation. For example, the list sort function, we use that the comparison. So we actually can sort this list and do a comparison. So in this case, once we sort that list, the first person is actually now Andrew Gates. Well, remember when we order this by last name, so it doesn't look like Andrew Gates will be the first one. Okay, let's see. We compare the last name. Well, if the last name is same, we compare the first name, right? So, so if the last name is same, we compare the first name. They are all less than operation. And since we implement the less than operation, this actually works. So which means the smallest word goes first. In this case, it's basically alphabetical order. So Andrew Gates go before Bill Gates. So Bill Gates is the second. If I print out every element of the list, this is their order. Right? So we can actually verify H go after G, W go after H, Z is the last one. So yeah. So there we so all this happened because that override function less than override. So yeah, it's really neat if you think about this. Yeah. So Python does this operator overload has some can lead some very interesting behavior of the classes. Yeah. So, okay, and this is the class definition of person. And the next example is the MIT person. And this is inherited from person. So this is a subclass of person. And the MIT person also has this next ID, which is a class variable. MIT person also overrides the constructor of the person. And to override that, it first call the default, which is the person.init, the name. And then what it does is actually assign a unique ID to each MIT person. And also the way it makes sure it works by advance the class variable every time an instance is created. So MIT person.next ID, that is the class variable. Self.id NUN is the instance variable. So there. This is a bit tricky when we're trying to use UML to describe this. We need to distinguish the class variable and the instance variable. And then there are some other functions, get ID, less than, and speak. Now the less than, basically, remember in a person class, we also have a less than operator override. And the person less than operator is compare the last name and then first name. But in the MIT person, we actually now compare what? The instance ID number. Remember, each instance has its own ID number. So we are basically going to base on each unique ID of the instance and order all the instance of the MIT person. And this, and to demonstrate the example, we create some new instances. So we first MIT person, M1, second MIT person, and third, fourth, and fifth MIT person. So now, if we actually now compare the first and second MIT person, remember we created this sequentially, so their ID should also be sequentially because the class variable increment by 1 each time. So if we compare the, I need to print this one out. That should be false because what the M1 had an ID of 50. Oh, this is also sequentially. I need to, because I run this multiple times. Hold on. I run this before the class, so the clock keep running. I need to stop the session and restart it. Restart and run out. Maybe that will work. Restart and run out. Okay. Okay, so so now if I run everything before, why is it taking so long? Still 15 and 16. Let me rerun this again. Okay, now it's correct. Well, I don't know what's happened, but now it's correct. So M1 had the ID of 0, M2 have the ID of 1, so that's correct information. But apparently in Jupyter Notebook or Colab, if I rerun this part of code, it's going to keep updating the code because the class variable is already there. So this is a bit tricky when you use a Jupyter Notebook debugging. You need to remember how many times you have run this class definition. So just something to keep in mind now. So. Okay, so M3. I should also print out that. That's also a logic. M3 should less than that should also be false, right? Because M3 is 2, M1 is 0, so that's false. M4 less than 1, M1 is 2. Oh, this is interesting. So notice M4, this is a person. M1 is MIT person. So when we call M4 less than M1, we are calling person dot. So M4, if we look at this, is not MIT person, this is a person. When we're calling M4 less than M1, this is actually not compare their ID, but compare their what? Last name. Yeah. But if we do this, if we say M1 less than M4, this is going to give us an error. Because apparently it taking, let's see, M4, because M1 is MIT person, you're going to try compare the M4 with the ID number, but M4 has no ID. So, yeah. But because they are all person, we actually can put them in a list. So M1, M2, M4. So, M3, M1, M2 here. So in this case, if we actually now sort the list, in this case, okay, one MIT person, two, three MIT person for the list we sort. This is okay. So this is going to sort based on this on the ID number. So the ID number basically, I think Zuckerberg is 0. These two Houston is 1. Bill Gates the 2. So I think Bill Gates graduated from a job from Harvard. Is it not at MIT? So, Zuckerberg also from Harvard. Anyhow, this is what the example is. So they are not all MIT persons. So, okay. So M1 dot speak now interesting. So if M1 dot speak, does the MIT person have a speak method? Oh, it does. Okay. So MIT person had a speak. So how do I go back? It does says utterance. So that's correct. Where did that go? Oh, yes. Yeah. M3, Bill Gates, since that's also MIT person, is also going to call. But if we call the person speak, let's see. Does the person have speak? No, the person does not have speak. Okay. And so, okay. And the next subclass will be student. The student inherent from MIT, and then grad student. Grad inherited from student, and transfer student from student. So now we have a one subclass and then subclass. So, and then we have another subclass of student, which is UG. The UG actually have a class year. Notice the UG constructor also have the class year there. So the UG must have a class year as the input for a constructor. And the UG also now override the speak method. The speak method was originally defined in MIT person, but the student now says, dude, what did the regular MIT person? Did that say hi? And then we can also, so, oh, have I run this one? Let me run this one. Okay, so now we define the student, Matt Damon, Ben Affleck, Lynn Montgomery, I don't know who this person is. And then a grad student, transfer student. So we kind of put all these students in a student list, even though they are different subclass of students. So, okay, so the first student, Matt Diamond, class of 1. And if we should if we call the S1.speaker and the S2.speak, it's going to talk like a student, I guess. Yeah. I recall from the MIT person, if we go back to the M1 person speak, they just say hi. So now the student now override the speak function. Notice the student inherits from the MIT person, so it should also have the ID number. This is actually number 8 now. I probably run, is it really number 8? That's one. I probably run this multiple times. Well, let's, Matt Deming is one. I must run one of the block more than twice. So, okay, let's ignore that for now. The S1 had the ID of 8. So. With those, since student also inherited from the ID from the MIT, so we could also sort them. So this is current student list. If we sort out a list, the order is now Madam, but not like me. Let's print out its ID. So see what's the. Okay. Okay, now this makes sense. So my diamond ID 8, everything ID 9. Okay, that is from smaller ID to the largest ID, so that's correct. So, okay, so next example, now we have another subclass of MIT person, which is a professor. And the professor override the MIT person constructor, but now the professor has the special instance variable called department. Professor also speak a little different. The professor speaks in course some the department, and that's plus the department plus we say something. Yeah. And the professor can also give lectures. This is kind of funny. It is obvious that something happened. So that's a pretty arrogant way to say something. Okay, anyhow, so let me run this. And the professor going to have a word. Dr. Arrogant, that's a new, that's actually his name, Dr. Arrogant. And then his department is what, Department 6. That seems to be a very weird department. And that's a department what? Nonsense. Okay, so now if this faculty speak, that would be Dr. Arrogant says in course computer nonsense, we say hi. Okay, whether that makes sense or not. And then when the professor gives lecture, it's going to say in our course, we said that it is obvious that physics is everywhere. That's kind of funny, though. Yeah. Okay, it's actually a bit comic version of an implementation here. So this actually not. So the professor should also have an ID. So if I want to find out this faculty's ID, I can let's get ID 13. So this already, that looks correct, right? The last one is 12. So now this, we just created this Professor Dr. Arrogant is now 13. Yeah. Okay, so this is the example of a professor instance, class, and its instance. And the next one, this is a little bit more complicated. This is now we create a class called Gridbook. And the Gridbook is actually independent of the person, MIT person, professor, all those things. But what this grade class does is a container. It's going to aggregate some instance of the previous classes. In this case, those are what? Student. So the grades going to contain a list of students, the plural, student object. Did we define a student? Yes, it's singular. Yeah, we define it. So the grade is going to contain a list of student objects. It also has a grade, but that's just instance variable here. So, but the student is actually a list of object of student. So, and the grade also has a class called add student, and so that student should be object of a student class. So. And this is also a good exercise to avoid the duplication of student. So it's also once we added a student, it looks like we also create the grades of that student based on its ID. So this is what? A dictionary. This is a map. This is basically a dictionary. Right. So, and we're going to use the ID as a key and the grades as a value. But when we first added a student, there's no grades. But we can then use another method called add grade. Add grade, not the plural, singular. For that student, we add a grade. So try self.grade, append grade. If not, then that student is not in the list. So we can get grades. If that student exists, we get. If not, the student not in the gradebook. Sure. This is actually a bit special here. We actually notice those try. We actually try return. So return successfully or not. So and we can also return all the student. So and when we return all the student, apparently we can sort out the student. This is because the students is a list. Okay? So we can apply the list function, which is sort function, and sort that list and return it. So, okay, so that's the grades class. And then we also have the helper function. So this is actually not a class. It's just a helper function. So Python is not strict OOP language. In Java, everything you write has to be a class. But in Python, we can just write a function, do something useful, but it's not part of the OOP design. So this grade report is just help a function to print out the grades reporting purposes. So it's basically going over all the students in the gradebook, and it's going to calculate the total and actually calculate the GPA look like. So, and then print out the report. So, okay. And then we have example to explain how the grade book and the student can be used in conjunction. So this will be an integration testing. So we have 4 undergrad with a class year there. We have 2 graduate students. And then what is this? This is the instance of the grades object. Right? So look at the grades object. Its constructor has nothing. It's basically, there's no input. We create an empty gradebook. So this is why here we create a gradebook apparently 600. That's actually apparently the class name at MIT. So we create that, and then we add student there. We add a student G1 and UG2, UG1, G2, UG4. Is that all of them? 2 graduate students, 4 undergrad. Yeah, that's all of them. And then we also add a grades G1, G2, UG1, UG2. But notice UG4 has no grades. So and then we also add the G1 with multiple grades. So, and then we print out then we print out the report. So the report will be okay. Let's see. G1 is which person? G1 is Bill Gates. And G1 has 1 grade 100, another grade is 90, so its average should be 95. Is it 95? Yes, that's correct. Yeah. So Bill Gates, the average grade is 95. So I'm not going to verify the other 3. Hopefully they are all correct. Yeah. So this is basically the gradebook report. We can also see the list. Print out all the student list and all. In this case, we can remember this is all the students are the MIT person, so we actually can also see their ID. So this has been increasing. So now it's 14, 15. Yes, those are sequentially increasing. Yeah, so yeah. Okay, so those. This is a bit very detailed implementation of OOP in Python, and there are a few key concepts here. We use a multiple inheritance, and we also showed there are multiple subclasses, but they all belong to a parent class. We can put them in one list as okay. Yeah. But once we do that, if we are calling a function, we need to be careful where that function will be invoked, because the behavior, in this case, the sorting function implemented twice. Once is by last name, once is by ID. So depend on the instance we have, it's going to invoke different behavior. So what other things? Well, there are some other small things, but that's actually Python data. Like how do we handle the data time? How do we handle the string? That's kind of Python idiosyncratic way of dealing with the data type and string. So, right. Okay. Any questions about this? This actually, you will have a homework assignment to draw the UML diagram of this class. So
I have a question about the UML.
Yeah.
You said the class has a class variable and an instance variable. Are those listed in separate places of the UML, or is it all in the part that has class attribute?
Those are all in the attribute version, but
how do you distinguish between the two, or is there a reason to distinguish?
Oh, there is clearly reason to distinguish them, but let me show. I'm going to use my iPad to draw this. So let's see whether I can. I'm going to stop my computer sharing and then use my iPad to draw this. See. Okay, this is not working. Oh, no, now it's working. Okay. All right, so let's see what I can show this. So we we have a person. Oh, that's that. Person has what? Name. First name. Last name. And then we have a MIT person. So, and now we need to distinguish the class variable and the instance variable. So the class variable is that's the class variable. The instance variable is ID. And that's it, I think. And then you put a method here. So that's the MIT person, and then you have a student. The student does nothing. Everything is inherited from that. And then we have a graduate student. Also nothing, it's just there. And then we have a transfer student. Nothing there. And then we have an undergrad, UG. Well, this one is has a class a year, and then some functions. Let's what else? Oh, professor. We have a professor. Professor actually goes from an MIT person there. So. Professor has department. And the professor also has a speak. utterance. Lecture, what topic? And then this is the interesting part. We have the Gridbook. Well, I don't have space anymore. Okay. Okay, this is I'm going to use a red. I'm going to have a, let me just draw this empty space. Is that singular, plural? Grades, it's plural. Okay, so we have the grades. And the grades have student. Oh, this is not easy. Okay, so. This one, grade is going to have a aggregate student, and it look like a 0 ... star. It could have 0 student. So, and then the grade has the some attribute students. That actually is that's how the aggregation is defined, and then the grades, and then is solid. Is solid, and some other things. Yeah. So yeah, I hope this is helpful. So
how could you tell that it was supposed to be that aggregation to student from grades? Yeah.
Oh, if we go back, let me, if I go back to my computer to share the. There. Self.student equal a list of something. So there, grades contain many instances of the student object. So that's if you recall, I actually also asked you a question: how do we distinguish aggregation from inheritance? So the grades is the as a class definition is separated from a person or student or MIT person. It's not part of that family tree. But what the grades does, it actually going to use a list of a student object. And so the student object will be add a student by adding them to it. So
is that where you would do the 1 ... star?
Yes, except in this case, I think it's the 0 ... star because it starts with the empty. It could have an empty grades.
Okay.
Yeah. So yeah. Good question. Yeah. Any other question?